This is Fan of Astronomy, Episode 4.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Welcome, everybody, and a very happy New Year's to you. Yeah, it's a new year, dude.
Oh, God.
Yeah.
Well, at least no more celebrities will die now.
Not in 2016?
No, in 2017.
None whatsoever are going to pass.
No celebrities will die at all.
Dude, that is going to make the 2018 Oscars in memoriam absolutely boring.
It will.
It's already bad enough. I mean, now I actually have to sit there and just watch a black screen for, 40 seconds. Actually, you know what? That'd be kind of awesome.
Sounds good.
Anyway, I am one of the hosts of the show. My name is Angelo, and I am here with the Swedish superstar himself, Mr. Dan Horning.
Hello there.
And watch how you say that. It's Horning, not horny. Think about that. Now,
It's actually Hörning.
I'm Americanizing it. You hush.
Yeah. I used to call Dan Horny in college, but that's another story.
That's why I said, watch how they say that.
Yeah.
They might get poked by some.
Uh-oh.
Anyway, digressions on top of digressions. So what we're going to do now is real quickly tell you guys about our Patreon.
Yes.
We have a Patreon. You should sign up for it. It's absolutely awesome because you'd pay us to do things. Like what things?
Like doing this show.
Oh, that's important.
Patreon is a contract between you as a dedicated fan of Astronomy and us. So you say, I'll give you X dollars, 2 perhaps. That's a good cup of coffee every month. And we produce episodes. And when we produce episodes, we get money. And when we don't, we get nothing. And if we hit $100 on Patreon, it's patreon.com/astronomy. And if we hit $100, we're going to do a special bonus episode outside of our regular bi-weekly feed. And what will that be about, Angelo?
That'll be about blowing everything up. Like literally, the universe just wants you dead. So we're going to talk about all the ways that it wants you dead. And for every $100 mark we reach after that, we will come up with a new exciting episode that we're just going to throw in extra until we reach the $700 mark, where all of a sudden this show will become a weekly show. And, I'll have a lot of more work to do.
Yeah, that will be fun.
Is it bad that I hope we get to $6.99 and just stall out there?
Yeah, that's bad. Let's go weekly. I want to go weekly.
Okay, so our subject tonight is one of the more interesting planets in our solar system, mainly because we know a lot about it. And
it's also our closest planet.
It is. It's very close to us. And this is, I love how you say it.
Venus.
You said it right this time. Like last week you were saying like Venus or something like that. And I was like, wow, if he slips with the tongue, that's going to sound terrible. Okay, so we're going to talk about Venus. It is currently the first and brightest thing in the night sky, sans the moon. That's very important. The moon is still brighter. At my location right now, where I'm sitting, as soon as the sun goes down, if I look southwest in the sky, bang, there it is, Venus. And I've actually been staring at it a lot over the last couple of weeks in preparation.
Did you learn anything?
It's sorta. Like visually by yourself, you can kind of see its atmosphere.
Wow.
If you look really close, you can kind of see a haze around the planet. And I thought that was fairly neat. And if you get a telescope out, like you can see the thing. It's not hard at all.
Its atmosphere is pretty crazy, so it changed a lot on the planet.
Not in your lifetime, but it has changed in its lifetime.
Yeah.
There's a difference.
Definitely.
Yeah. So we often call this our sister planet. And the reason for that is it's only a little bit smaller than us. And it's basically built of the same stuff as we'll talk about in a moment. Okay, so it has a diameter of 12,104 kilometers. Or for, you Americanized people like me, that's 7,521 miles. So it's very similar to Earth. And when I say diameter, that's if you look at it, bang, there you go. It's not the full radius. Radius, diameter, two different things. Got it? Good.
I would say that if you look at Earth and Venus not next to each other, then you can't tell the difference.
Not really. It's as far as size goes, it's 81.5% the size of the planet Earth. And when you're talking about things this big,
that's the mass, right?
I don't know.
Yeah, it's the mass. The diameter difference is only 65 650 kilometers. So it's really small.
Oh, okay, yeah, fair enough. Where I got my facts did not quite mention that. So I guess you learn stuff doing things like. However, one of the big differences between us and them, we got a moon.
Yeah, Venus really needs a moon.
Has no moon, it has no rings, but you said it has some other stuff.
It does. It has these small rocks that like it. So it does have some Trojans. It has. Now I lost my notes.
Woohoo!
Only professionality here.
Always prepared. So glad.
Yeah, it has several Trojans. It has a quasi-satellite that is making a very good impression of the moon, but it's orbiting the sun really close to Venus. It's we can't tell how big it is. It's 210 to 470 meters. It has the glorious name of 2002 VE68.
I'm gonna call it Bob.
Bob is looks like it's orbiting Venus quite far out. It's 0.2 AU. But it doesn't, so it orbits the sun. We used to think that Venus had a moon. It even had a name. It was called Neith.
It should be Bob.
It should be Bob, but it was Neith. And it was discovered. Obviously it wasn't discovered, but it was reported in the 17th century. And there was numerous sightings of this moon for 200 years. But then we sort of learned that, oh no, it was stars behind Venus that looked like a moon.
Oops.
So disappointing.
Very much so. So, Venus is close to us. And by close, I mean very close. It orbits the sun at 0.73 AUs.
Yeah, and because Earth has not entirely round orbit, there are moments when Venus comes within 45 million kilometers. And that's close in the solar system.
Yeah,
and it's about 10 million kilometers closer than Mars ever gets.
Yeah, so, I mean, this is the closest planet to us. We look at it, again, we call it our sister. And part of the reason is, like, when it gets really, really, really close, it reaches about 3/4 of the way from the sun to us. Yep. So, I mean, that's like, almost knocking on the door, hey, can I get some sugar?
That's the launch window as well, if you want to go to Venus. That's when you want to hit Venus. Of course, when it's on the other side of the sun, it's pretty far away.
Yeah, it's not close when it's there. Its rotation is not the same as ours, as we'll find out. Okay, so, funny thing about Venus. We used to think that it could be a tropical paradise. And then in the 1960s, so not really that long ago, 50-some years, radio mapping technology finally came about and we found out, no, this is not a tropical paradise. This place is hell on Earth, but on Venus.
Yeah, it's hell. It's 462 degrees centigrade on the surface. That's hot enough to melt lead. It's hot enough to melt zinc. And if you are any stronger metal, you will stay in metal shape. But yeah, it's hot.
You'll be very red though, regardless.
Yeah, and it's hotter than Mercury.
Yes, it is. It's the hottest one in our solar system. And it can reach as high as 471 degrees Celsius. So,
good day.
So, I mean, that's warm. That's very warm. And the reason it's so hot is because its atmosphere is comprised of 96.5% CO2.
That's horrible.
Carbon monoxide. Or dioxide.
Dioxide. Yeah.
Yes. Monoxide would be CO1.
Yes. This is, of course, the runaway greenhouse effect. So there is speculation that Venus once had oceans and the sun heated Venus up too much. There was a greenhouse effect going and then the oceans vaporized and the most dangerous greenhouse gas there is water. So once that happened, everything went crazy and now it's super hot.
Yes.
I did do some research on the temperature of Venus should it not have a greenhouse effect. So the real temperature of the Earth is 15 degrees minus Celsius. So 15 degrees below freezing if we didn't have a greenhouse effect. But the greenhouse effect on Earth today, the natural greenhouse effect or the slightly changed greenhouse effect is about 30 degrees centigrade. So the Earth is as nice as it is because of the greenhouse effect. So if you totally remove the greenhouse effect on Venus, you get to a temperature very similar to what the Earth has now. But that means no atmosphere. So you probably need some sort of atmosphere, then you get a greenhouse effect. So, but it means that the original idea, before we knew anything about the atmosphere there, that Venus could be a tropical paradise, is not that far-fetched. But this tropical paradise has burned.
Yes, it is bad now. And part of the reason for this is we have discovered, so we know of over 1,000 volcanic centers. I can't even call them volcanoes because these things are larger than 20 kilometers. We found over 1,000 of them just on the surface.
That's bad news.
Yeah, I mean, it's just constantly spitting volcanic ash and everything into the atmosphere. And hey, I mean, go look at pictures of Mount St. Helens and what it did to the Seattle area after it went boom. And think of that on a much larger scale.
There is only one volcano on Earth that would fit in the team of Venus volcanoes, and it's the big island of Hawaii. It's the only one that's big enough to be able to show up on Venus and like, I am a volcano.
Yeah, but that's the above ground volcanoes. Like underneath, what is that, Yellowstone Park, there's a super volcano thing there.
Yeah, then we're talking about supervolcanoes, and I'm sure there are supervolcanoes on Venus as well.
Yeah, and I'm sure that our supervolcanoes can match the 20 kilometers. But, I mean, that's what we're talking about.
Maybe there aren't supervolcanoes on Venus because they might require a more active plate tectonics thing.
They might just spit out too much crap that they never get to build up. You know what I mean?
I'd like to add one thing about the greenhouse effect on Venus.
Yes.
The water is now gone. It has left Venus. So you can't sort of reverse stuff and get the water down and get the oceans again. It's beyond rescue.
Some tropical paradise this is.
There is, of course, if you go up a bit in the Venus atmosphere, you will find places that have Earth-like temperatures. So if you are about 50 kilometers above the surface, you have a nice Earth-like temperature. But then you are in the region of the acid rain. It rains sulfuric acid on Venus, but it doesn't hit the surface because it's so hot that the sulfuric acid can't get down to the surface.
So sweet. We're 50 kilometers up and we're in LA. Awesome. The thing is, like, we hear about this runaway greenhouse effect thing all the time, and people say that this is the future of Earth. And in many ways, it's thought that it could be, but this is a very long-term thought. But, you know, I see that you found some research saying that maybe not.
Yes, the IPCC, the United Nations Council on Environmental Change, they have received a lot of criticism for their work, but they are one of the big authorities on climate change, and they have they've stated that there's simply not enough carbon on Earth that we can, even if we burn all the oil, all the firewood, etc., we can't get enough carbon into the atmosphere to create a runaway greenhouse effect. We could, of course, make the planet uninhabitable for humans, but we can't get a similar effect to Venus. But the sun can, so eventually the sun will create another Venus of Earth when it vaporizes the oceans in about 1 billion years, give or take, a lot of years.
Wow.
But we can't do it.
That's just so positive.
Yeah, that's great news, isn't it?
Yes, we have 1 billion years and then you're all going to die. So
Did we mention the atmospheric pressure?
I did not quite get to the atmospheric pressure.
Right. You go ahead then.
This is heavy.
It's heavy. It's really heavy.
92 times greater than Earth is the atmospheric pressure on this planet. So basically, this is like sitting at the bottom of the ocean.
It's a kilometer down in the ocean.
Yeah.
That's a lot of pressure.
Think of all that water weight on top of you. That's just what it's like sitting on the surface with nothing on top of you.
Think about those submarine movies when they have to go down and it starts creaking and water is pressuring onto the submarine. It's like that, but worse.
So are we going to find like strange fish that have like goofy lights on top of them on Venus?
No, because they need to be able to swim in carbon dioxide.
Yeah, and there's that no water thing. Huh. Well.
Yeah, and it was fun times for the Russian probes that they sent in the 60s and stuff because they got crushed.
Yes.
The original ones.
Yes, but the Russians though were the first ones to get one there properly.
Yes.
So, I mean, that says something.
And they had an amazing way of doing it. It was like send a lot of probes, watch them get crushed, make them a little stronger, send another one, watch it get crushed, etc. Until they actually landed on the surface. And I think that one survived for 90 minutes.
And then it got crushed.
Yes.
So
And going through the sulfuric acid rain was, of course, a problem as well.
Yeah, that probably weakened its structure. So you're probably wondering who figured out that Venus was there, and that was first recorded by Babylonian astronomers in the 17th century BC. So there's your Babylonians. Yeah.
Were they the ones that figured out that it was just one object?
No.
Because you tend
years.
to think that it's two objects, because Venus either appears at dawn or dusk.
Yes, and I have that a little later in the notes, so we'll leave that one be for now.
Okay.
Okay, so we do know, again, when I said that we call it our sister planet, it has a molten iron core, it has a rocky mantle, it has a silicate crust. Is there another planet like that?
It sounds like the Earth.
It sounds a lot like the Earth. It's built exactly like us. So, I mean, this is exactly what we expect. A solar day on Venus only takes 117 Earth days. However, a sidereal day takes 225 Earth days. And an orbit around the sun takes slightly less.
What's a sidereal day?
I'm not 100% sure. I believe it's a full rotation.
All right.
Not just New York's in the sun and now it's in the dark, which takes about, on Earth, depending on time of year, anywhere between like 14 and 18 hours.
Yep.
So that would be a solar day. That's the time you can actually see the sun. And a sidereal day is the actual full rotation. And so this is another planet that has longer days than years, just like Mercury.
Yeah, that's crazy. And here we have there is no gravitational locking to the sun like on Mercury.
Nope.
We just have super slow rotation of Venus.
Because it's going the wrong damned way.
Yes, it's going the wrong way. It's crazy.
It's the only planet we've discovered that is in what's known as a retrograde rotation. This is where it goes backwards.
And it's important to be clear here. All the planets go counterclockwise around the sun, Venus as well. But most planets go counterclockwise around their own axes. Like everybody does, except Venus, which goes clockwise around its own axis. Yeah, and super slowly.
And it's not just the planets that do this. It's galaxies do this. They move in the same direction. And this one, it just goes, no, I'm not going to. So we believe that it must have been hit by something really hard that actually spun it the other way.
I found 3 theories on this, and one did not involve a collision. It involves like tidal forces from the sun. It's pretty complicated. Why would the sun do this just to Venus? But
leave Mercury.
Apparently the theory checks out. The other theory is a Theia-like collision like Earth experienced when the moon was created. And the third theory is that Venus actually had a moon that crashed onto Venus. And Venus is very good at hiding evidence of crashes. So Venus doesn't tell us if anything hit it longer ago than 500 million years because of a very strange phenomenon.
Yeah, called over 1,000 volcanic centers.
No, it's even stranger than that. It seems that Venus resurfaces itself entirely. That as there are no plate tectonics on Venus, pressure builds up and the volcanoes can't release enough of it. And then at some point, and this has happened several times, but we don't know how many, but we know that it happened about 500-600 million years ago, that the Venus surface was entirely erased and resurfaced. So every crater impact that is older than that is most crater impacts. The great bombardments and stuff happened earlier than that. It's just gone. Venus got a brand new surface at some point.
Yeah, it kind of has, we have plate tectonics. It has replacement theory, and it is from basically the lava. You know,
we should be very happy that this doesn't happen on Earth, because it would erase everything on the planet.
It would be catastrophic.
Yeah, it would be entirely lethal for everything.
So that's terrible. But again,
it's weird as well. Yeah.
Again, whether it's the moon hitting it that it once had or something else hitting it, something big hit this damn thing, most likely. There's the tidal force theory, but I have a hard time believing that because it just, Mercury.
It was super complicated, that theory. I sort of gave up on it.
Okay.
I read about it.
All right. Well, you're pretty damn smart, as I learned. So if it was too big for you, then I'm just going to let it go. Okay. So we often have called this star or this planet the morning star and the evening star because early civilizations thought that it was two separate objects. And the Greeks, they called it Phosphorus. It's like they knew how hot it was. And Hesperus.
That sounds hot as well.
It does. But the Romans, and I love this, the Romans called the morning star, think about this, Lucifer.
Yes.
And the evening star was Vesper. So there's an obvious Christian reasoning why the devil is often called the morning star. It all comes back to Venus. It's like everybody knew it was hell.
Yeah, it sounds like that, but they didn't know it was one object.
No, they had no clue. But I mean, the morning star somehow stuck with the devil. Lucifer, is the given name of said deity, I guess. I don't know. It's religion. So I mean, there's like an obvious thing there where it's like, well, I mean, stories get passed down and what have you, and that's where the Christian thing comes in, where the devil is called the morning star because in Christian mythology they call the devil Lucifer.
Yeah, and in the great novel and movie 2010, when the aliens managed to ignite Jupiter, making it into a red dwarf star, they name it Lucifer as well.
So Jupiter's Lucifer? Oh boy. Oh boy. We're surrounded by devils. We're all going to die.
Yes, we are, but probably not because of the devil.
So currently, though, we have named it after the Roman goddess of beauty and love, Venus, which is the exact same thing as what the Greeks and most people know as Aphrodite. Everyone knows who Aphrodite is. Well, the Roman name was Venus. Got it? Get it? Good.
Yeah.
So,
and of course, I can't resist trying to colonize Venus.
Of course you can't.
Because this is a planet and it's close. And of course there are some difficulties then, as we have stated. The atmospheric pressure, the heat, the lack of water. Pretty
the volcanoes, hard. The fact that it replaces its own surface. Okay.
Yes. So what we do, of course, to build cloud cities, we get to this nice spot where it's Earth-like temperatures, 50 kilometers above the surface, and we somehow manage to shield ourselves from the sulfuric acid rain. And then we have a nice solar energy because the sun, of course, never reaches the surface, but it does reach this spot 50 kilometers up. So then we just need to have a balloon that somehow stays afloat all this time. Of course, if you have Earth atmosphere in the balloon, it will stay about 50 kilometers above the surface of Venus. So that's promising, right?
No.
But then we have the problem of the super slow rotation. So you have these days lasting over 200 Earth days. But there are, of course, storms on Venus. And at this level, at the 50-kilometer layer, we have storms that they are like super hurricanes. And but you could travel on these storms and get around Venus on after 4 days. So you would only have like 96-hour days. And that's
96-hour nights. Yeah, that seems good.
Or no, 96-hour day-night cycles. So you would have like 48-hour nights and 48-hour days. There are no seasons on Venus because Venus is pretty much standing straight up, like Mercury. Not as much straight up, but almost.
Yeah.
And not tilted like the Earth. And of course, this means that Venus is probably a worse place to colonize than Mercury. And a lot worse than Mars. The gravity is a good thing. We have gravity similar to the Earth.
Yeah,
so that's a big advantage.
Just slightly weaker than ours. Ever so slightly, almost unnoticed.
Yeah, you would weigh about 90% of your current weight, or 81% then. Yeah. So that would just be like, you would be proud of your weight.
Would I be? Your mass
Prouder.
does not change.
So. And then, of course, the other way to do it, as we know, if there was no atmosphere, we would have a nice temperature on Venus. So we could terraform Venus, and then we have to get rid of this crazy atmosphere. And there have been several proposals how that could be done, but you would have to bind the carbon dioxide somehow. and that seems pretty hard.
Ooh. I know how to do it.
Tell me.
Have you ever seen Spaceballs?
Yes.
You get the giant lady with the vacuum cleaner.
Oh, now that's the way to do it. Yeah, that's actually almost the point here, because it's probably easier to remove the atmosphere than to try to bind it to something.
Yeah, we still have this lack of water. Still have a lack of water. Still have.
Yeah, so what you would need to do is to take a space rock, 700 kilometers big. You could probably find one in the asteroid belt, hit Venus with it, and that would eject all the atmosphere.
Wait. Have you ever seen the end of Spaceballs?
Yes, I have.
She doesn't just suck, she also blows.
Oh, no.
So we can suck up water and blow it down on it.
And then there has been a lot of theorizing about how to cool down Venus. So you would use like mirrors in space to get the sunlight away from Venus to cool it down. And this, of course, could also be done to the Earth. So there is some serious research on that, but it's, of course, science fiction today.
I mean, it is, but the mirrors are only going to cool it so much when you have a pressure that's accurate.
Yeah, and then you, of course, you would have to introduce an Earth-like atmosphere or something like that. But Venus could hold an Earth-like atmosphere, which is good. And it turns out that these enormous long days is an advantage for holding the atmosphere. So it's easier to hold the atmosphere on Venus than it is on Earth.
That's interesting.
But it sounds like a project that will take some time to do.
Little bit. It does have a magnetosphere, so that's good.
Yeah, but it's crazy weak. It's much weaker than it should be.
Right.
So something is wrong with the core of Venus.
I think it's because the core is constantly spitting its shit out.
No, it's probably that it could be that it isn't spinning at all because of the slow rotation. That our rotation makes the Earth core move, creating the magnetosphere. But Venus is just too chilled to just hanging around there. So slowly going around itself. So the magnetosphere can't protect the surface from the sun. And that's, of course, an enormous problem. Another enormous problem with living on Venus.
So this is a good idea.
Yeah, let's do it.
Dang it, there went that PG. I actually swore. Well, there went the PG rating. Ain't no point in keeping it now.
Now, do we really have one?
We haven't used naughty talk yet. I think that was the first real swear word.
Okay, ignore that.
Yeah, ignore that shit.
Don't report us.
Okay, well, I mean, those are not good ideas. I think we should probably look to other planets before we try to do all this work for.
I think there are at least 10 places that are better to colonize in the solar system than this hell planet.
At least.
Yeah.
I think realistically we have a better shot of making it onto a planet outside of our solar system before we
like Proxima Centauri B.
Possibly. Before we actually get all this work done to Venus so we can live on it. Be a hell of a vacation spot, though.
Yeah, sauna planet.
Oh, terrible. We're going to take a quick break so my lovely wife can come in here and talk to us about Facebook, and we will be back in a moment.
Hello. Are you enjoying the show so far? I hope you are. Well, if so, I encourage you all to pause the show. Don't worry, we'll wait. Go to facebook.com/fan of astronomy and hit that like button. You'll be one of the first people to know when a new episode comes out. Also, on that page, the guys post articles on the latest news in the astronomy field and outer space in general. You also get to interact with the hosts of our show, Dan and Angelo, there, so please hit that like button on Facebook. Thanks.
Well, folks, it's time for the news again, and again, we have a bit of sad news.
No!
Yeah, I know, it's pretty terrible stuff.
Princess Leia died. No, that wasn't what you were going to say.
That's not what we was going to talk about, but that did happen. But on Christmas Day, Vera Rubin died. Now, I know that she's not exactly a household name, but, I mean, she lived a long life as well. She was born July 23rd, 1928, and she died Christmas Day 2016. So, you know, she got to see a lot. Couple world wars. She's from Philadelphia originally. She went to Princeton. So very, very, very smart astronomer. The reason we're talking about her is because she is responsible for a thing we call dark matter.
Oh, yes.
Her work in galactic rotational curves predicted with angular motion that there was something wrong. And this is known as the galaxy rotation problem, because none of these galaxies should have formed based off of what we knew at the time, there had to be an extra substance out there. And that's where we came up with the theory of dark matter. So what galaxy rotational problem is a discrepancy between observed galaxy rotational curves and the theoretical prediction, assuming a centrally located dominated mass associated with observed luminous material. Okay, are you following me so far?
Let me break that down. She looked at galaxies and discovered that these things are 10 times heavier than they should be. If you put the mass of all the stars together, the galaxy weighs 10 times as much.
Yes.
And imagine putting that theory forward to other scientists. She must have sounded crazy.
Specifically a bunch of men.
Yes.
Because this is a woman who, kind of broke a barrier. And she noticed that the mass to light ratio was just way off. And, the law of gravity is real, so we know that. And it's like something's off here. So without this woman, we would have no knowledge of dark matter being in the universe whatsoever. And, she lived a good life, and we thank her for her contributions to science in general and astronomy specifically. Right, Dan?
Absolutely. We will dedicate a full show at least or more to dark matter. It's one of the big mysteries in the universe because we still don't really know what it is.
Yeah, we know it's there, but we don't know what it is, what it looks like, how to grab it, how to hold it, how to do anything with it. We just know that it has to be there.
Yeah.
So, and that's because of this woman. Thank you. You lived a long life, and, you definitely left your mark on the world, even if she's not a household name. She probably should be. That discovery is on Einstein's level.
It sure is.
It is the finishing of E equals MC squared.
Yeah.
It
you know
really
what,
is.
Angelo?
Yes, sir.
I discovered that we actually have an explicit tag on this show, so you no longer need to restrain your language.
Wait. So why the fuck have I been watching what I've said for the first 3 episodes?
Maybe I just wanted to see if you could.
Of course I can.
Yeah, so now you heard Angelo being the charming gentleman, and now you will see his true nature.
Yeah, this is kind of messed up, because when we first talked about this, you was like, I want to do a show where we're allowed to swear at everything, but I don't know if a science show would be the right one. So I'm like, all right, I'll watch what I say, because I've been on plenty of podcasts in the past as a guest where I had to watch what I said. And then you go and give us an explicit tag and don't tell me.
That's true. I was also uncertain if I could swear in a foreign language, because English is not my native language. So I was thinking that, maybe I can't do it believably, but I know you can. And I don't swear in any of my other podcasts, and I never have. But now I'm going to give it a fucking shot.
Yeah, I can swear very convincingly. So apparently I'm not going to hold back anymore. You're going to hear my thoughts without, words like darn it and dang and those type of things you'll actually upset. Thanks for informing me.
For listeners.
Yeah, it's about to get. Yeah. But we do have some cool things to talk about in the news as well. It's 2 news stories in 1 episode. What about this? Haha.
Just for you guys.
No, this is more for you. We have to talk about this.
Yes, we do have to talk about this.
So,
of course, our baby is Proxima Centauri b, the closest exoplanet to Earth. We talked about that before, but there were news about it.
There was a lot of news about it, and it basically comes from one study by Dr. Dimitri Atri, an astrobiologist from the Blue Marble Space Institute in Seattle, Washington. He conducted solar flare impact experiments, which he modeled off of Proxima b. He took account of 3 factors: type and size of stellar flares, various thickness of atmosphere, and the strength of said planet's magnetosphere. And through this study, he concluded that if a planet has a good magnetosphere, a sizable atmosphere, effects of solar flares would be insignificant to life, even during an active phase.
Wow. Even with a red dwarf star?
Yes, specifically on a red dwarf star.
That's amazing. So that means if the planet is Earth-like, if it was like the Earth, it would be able to sustain life in its current location.
Here's the problems. Okay, we've talked in the past about it being possibly solar, or is that the right word? Yeah, locked.
Yeah.
Okay, we've talked about it being locked. Problem with it being locked is that means it has no magnetosphere. because
that's the problem.
it has to spin to make that thing happen. So we need a good magnetosphere. So problem one. But if
It didn't say anything about that, right?
It says, concluded that if a planet has a good magnetosphere and a sizable atmosphere.
Yes. Yeah.
Okay, that's kind of the conclusion here. So if it is spinning and it has a nice sizable atmosphere, Proxima Centauri could be like livable.
Is there no other way to get a magnetosphere? We know there are weak magnetospheres on Mercury and Venus.
Yes.
But so they, at least the one on Mercury has another cause. But these causes probably can't be strong enough to create an Earth-like magnetosphere.
Yeah, we're talking very small magnetos when we're talking about those planets. So
Yeah.
I would think that the spin would be important.
So this becomes the big question of Proxima Centauri B then. Is it tidally locked or not?
Yep. What is the spin of this thing? If it's spinning, we're good. Maybe. If it's not spinning, then the shot is probably...
So if it had like a crazy rotation rate at the beginning, it could still be spinning.
Yes.
With the star trying to slow it down.
Yes.
Making it just right now.
So you're talking about a Goldilocks in the Goldilocks zone.
Yes. Yeah, that's what I'm talking about. I want the Hobbit ninjas to have a nice planet.
Hey, whatever you want the Hobbit ninjas to do, they can do. You want a Goldilocks in the Goldilocks zone. Well, we all know what happened to Goldilocks.
She got all the food and got out of there.
Is that what happened?
I hope so.
Okay.
In my version, that's what happened.
Maybe it's just my version in my sick, twisted mind. I always pictured the big bad wolf.
They were bears.
Oh yeah, that's right. I'm thinking of Little Red Riding Hood.
Yeah, we're not talking about Little Red Riding Hood zone.
Yeah. So Goldilocks zone.
Okay,
they
don't
had bears.
fan of astronomy for your fairy tale knowledge.
Yeah, I'm not real good on fairy tales because they're fairy tales.
That's another podcast.
Yeah, same reason I'm not real great on religion. Anyway, so, all right, so the three bears. Okay, all right. Yeah, that's still not good. She had pissed off bears chasing her.
Yeah, but the Hobbit ninjas could handle that.
They are ninjas.
Yes.
Can we get Hobbit robot ninjas?
Yeah, that's a big possibility.
Hobbit
90% certainty.
Hobbit robot ninja pirates.
Oh, that's far. That's too far.
Aw. So we got an iTunes review this week, Dan.
Oh, sweet. We want iTunes reviews. Please give us iTunes reviews.
Yeah. Go on iTunes, hit that 5-star button, and then you can say pretty much whatever you want, and we're going to read it on the air. So this one,
if you're listening to this on another platform and give us a review there, please email us and tell us you did that. Then we'll read that too.
Yeah, like
but
on YouTube.
We don't get notified about them.
Like if you're on YouTube and you write a big comment that basically is a review of the show, let us know, and we will read that on air. But this one is titled, Dan Horning is Smart. So apparently I can just shut the hell up.
Nice title.
And this is written by Tony ADPX or Tanya DPX. I'm going to say Tony. I'm going to say Tony ADPX. He gave us 5 stars.
Oh.
And he writes, Fan of Astronomy is a great podcast, informative for the layman and otherwise. It's a very easy listening, and the co-hosts seem to get along great. Definitely in its startup stages, but once they get their stride, is only going up. A recommended podcast for anyone who has an interest in the great unknown. Oh, and Dan Horning is amazing.
Thank you, Tony. It's the accent. It makes me sound smart.
It's completely the accent. I've gotten to know Dan pretty good over the last couple of months. It's the accent. But then again, I can always shut the hell up.
No, please don't.
The show would be different.
It would be.
So remember, guys, go give us that 5-star review on iTunes. Hit that like button on YouTube. Let us know that you're listening. We appreciate it very much. And if you decide to become a patron for us, we will absolutely thank you for doing that. We will do that on the air.
Tell them our email address, Angelo.
Our email address is aofcast@gmail.com.
Astronomy fans.
Yes, I know it's backwards. Shut up. I know you're thinking of saying bad things to me. Shut up. Sometimes words are bad with me, okay? So.
Okay, I'm shutting up.
All right. I was talking to Mike.
Okay.
Yeah, he's sitting there. He's in his cubicle. He's listening. He's going, that dude's a dumbass. And I'm like, well, I can't really argue that, but don't tell me that. So, but we will thank you. please, go to patreon.com/astronomy and become a patron. We thank you right here. And if you send us questions to the AOFcast@gmail.com, we will answer them. We asked for them last week. We got 0. Let's try and get some for the next episode where we're going to talk about the moon.
Yes, the moon. Not a planet, but still significant.
It is larger than objects that we called planets. So
yes.
Think about that. It absolutely deserves its own episode, even if it is just basically our shedding.
So strange, the moon.
Yeah, we're going to talk about that quite a bit. We're going to talk about the moon landing, of course. But if you have any specific questions you want us to answer, please get those emails to us, and we will do that. Dan, if people wanted to get a hold of you because you're amazing, how would they do that?
I'm on Twitter as Dan Horning, and I'm on Facebook as Don Hörning, so you have to put 2 dots above the O.
That's, what's that called? Is that an umlaut?
Umlaut? Yeah.
Umlaut, yes. I thought that's what that was called.
That's true. I do 2 other podcasts in English and 6 in Swedish. But if you are interested in English ones, they are Fan of History, where I discuss ancient history, really ancient history.
Which, by the way, I actually do recommend it. He does a good job of talking about the old shit.
Yeah, it's before the Greeks and the Romans.
Yeah, and you know why?
Assyrians and Babylonians.
And you know why he does a good job? Because he's amazing.
Thank you, Angelo.
What the fuck?
The other English podcast is Game of Thrones Chat, CHAT, where we go deep into Game of Thrones. We've done season 4, season 5, and season 6, and we are ready to do season 7. So check that out on iTunes. It's on YouTube as well on my channel, Hard Nerd Cafe. Cafe? C-A-F-E. Cafe. Yeah.
Too bad that HBO isn't ready to season 7 yet.
Oh, they will eventually.
If you wanted to get a hold of me, you can get a hold of me at FOAAngelo on Twitter.com, and I'm PG there. So, and honestly, recently I've been tweeting a lot, but my schedule is opening up now that the holidays are over and my busy is done. So I should be tweeting more things. So please give me a follow there. Also, if you want to go to the Facebook group, that's facebook.com/fan of astronomy. I almost said history. Fan of astronomy.
That's a Facebook page too.
Yeah, go on both. Hit that like button. And we do post things on there about, neat, interesting scientific things we find. And look, we also post exactly when the show goes. So if you don't subscribe for some reason, like you're bad at, I don't know, electronics,
right,
then you will be able to go on Facebook and it'll say, hey, the show's up, and you'll go, all right, I need to go download that. So you'll know that right away if you're on there. So new year, hopefully good things.
Only good things.
Only good things here. We have a packed year already scheduled out for all of you guys as far as the show goes. We're going to finish the solar system, we hope, this year.
Yeah, we are still discussing how much detail we'll go into, but we'll get back on that.
Yeah, but, until next time, the universe is a big, amazing place that we're just scratching the surface of discovering. Please pay attention to the science. Always interesting, always surprising.
What'd you think? Did you enjoy it? Well, if you did, head on over to patreon.com/astronomy and pledge to these guys. For each patron they receive, the more they will be incentivized to improve the show. So help them out so they can help you out. Throw them a couple bucks an episode. They will really appreciate it. Thanks.